welcome to today's lesson. So the first lesson that we had, we looked at investigating some triangles. We looked at the bigger idea, which was a right angle triangle. We looked at things that we can do given that a triangle is right angled. That is using the theorem of Pythagoras, also using the ratios. Now we're going to use the ratios in specific, because I know that using the theorem of Pythagoras, you are very familiar with that and you can maneuver your way around it. So now we're going to go deep into what exactly does it mean to use the ratios and see exactly what is it that we need to do in terms of using ratios to either find sides or to find angles that are given. We're going to then spread this and go forward to doing also expressions and some equations just to see exactly what does a ratio do for us. And then we will then conclude it with looking at also some special angles and see how we then use the special angles in a triangle. Remember the first lesson we had, we just spoke about this in a nutshell and in a very, very broad way, right? We didn't really get into great detail. So that's why now we're going to then use them and show you exactly what is it that you need to do when you are using them. So that's what we are doing today. Stay tuned with me. Now, excuse me, remember we are using trig ratios, and with trig ratios, one thing that I want you to think about is, do you ever just take a moment and think about which fields do we apply certain concept of mathematics in? But in this one specific, like which fields do we apply trigonometry in? The reason why I'm asking this, by the way, just so that I can explain, is I know that most people think, why do I need maths? Because math, I don't use it in real life. But this is one of the examples I'm going to show you exactly where do you need your trigonometry. Because people always think, where am I going to use solve for x? Where am I going to use this concept? Where am I going to use this concept? But here, I'm going to show you exactly where you're going to use trigonometry. And I'm just going to give you 3 examples. And I'm sure you will relate to these because you see them every day in our everyday life. The first one is when we are trying to navigate our way on sea, right? So people that are sailing, they normally use trigonometry just to try and see if they get to a certain point, will the sun still be there, or in terms of time and all of that. Because remember, on sea level, you really cannot tell using the weather system like we always said on the news that tells us that tomorrow it's going to be 28 degrees Celsius or something like that. So they normally use trigonometry there. Also, we use trigonometry in planning, right? Planning our buildings. This is architecture, which is normally when we are trying to draw plans of houses that we're going to plan. Buildings that are very high, they use trigonometry to do that because there's angles of elevation, depression, there is lines that you need to look at, excuse me, all of those things. That's what we use trigonometry for. Also, we use this in terms of bridges. I'm sure this one, you always see a bridge. When you're crossing a bridge and you see that it can carry maybe 20 cars as they are passing or crossing the bridge, I'm sure you normally will ask yourself, how did this come about? Who actually designed this? The people that designed it were people that were very familiar with mathematics, especially trigonometry, and other concepts of maths, by the way, because remember, trigonometry is about angles, sides, triangles, and all of that. And you'll see as you progress with your mathematics career, there is a broader picture of looking at what trigonometry is all about. It's not only limited to triangles as we are doing at this present moment. Now, today our concept map will actually be right angles. That's the first thing that we're going to just try and revise. We're also going to revise ratios and the reciprocals. We're also going to revise some special angles. By the way, we're going to add 2 special angles, but I will tell you all about them. Also, we look at the last thing that I said was expressions and equations. Remember, expressions, it's when there is no equal sign. It's when you express something. 2x, that's an expression. 2x is equals to 0, then becomes an equation. So just remember those concepts. But for now, let's look at a quick recap of what right-angled triangles are all about. Now, our key words with right-angled triangles, remember, there's ratios that we're going to look at, some special angles. Now, with a right-angled triangle, remember, it is a triangle that contains a 90-degree angle because of that right-angled triangle. And I know at times we look at also right polygons or prisms. Please don't make the mistake of thinking about 90 degrees all the time there. So also two other acute angles, remember that. The side opposite the 90 degrees, we normally call it the hypotenuse side. Remember that as well. Now, we also have what you call the names of sides in relation to the angle theta. I just said now that the longest one and also opposite the 90 degrees is called the hypotenuse. In relation to theta, the side just next to it will be called the adjacent side. And in relation to theta again, the side directly across it will then be considered the opposite side. So this will be the adjacent side. So those are the names of our sides in relation to the given angle. Remember, you don't just call out sides based on just it being a side. There must be an angle that you are given, that you are using as your frame of reference. Now, with right-angled triangles, you know that's what we've looked at. Let's just look at the ratios as well. Remember I said with the first lesson, a ratio will be the comparison of two quantities of the same unit. One example I used was about rands and kilograms. Remember, you can't really compare those and look at what does it mean to have a rand as compared to a kilogram. Not really. Although, you know, when you go to a supermarket and you want to buy something, they normally sell it based on how much it weighs. But that's not a ratio to be exact. In trigonometry, our ratios are normally given as common or decimal fractions. You need to know that. So I can give it to you as either 0.5 or as 1/2. It means one and the same thing. Hence, I'm using the word or. But we normally give it as common fractions or decimal fractions, and not necessarily just a whole number. But you know that every whole number is a fraction divided by 1. There's also 3 trig ratios that we look at, and they have their reciprocals, which are also 3. So in total, I have 6 ratios that we look at in trigonometry. Now, the ratios and their names were sine theta, which is opposite over hypotenuse. Remember, I said it can also be OPP over hyp. Cos theta is adjacent over hypotenuse, which I also said it can be ADJ over hyp. And then tan theta is opposite over adjacent. I'm also going to give you what we call a mnemonic to try and remember these definitions, because we call them definitions, by the way. And the other thing is, should I say to you, define sine theta, I don't want you to then go to an Oxford dictionary and then start talking about a sine theta is a sine that doesn't exist. When I say define it, I'm saying give me what is the ratio of sine theta. Now, the memory tool that I said I'm going to give you, please remember this phrase as your mnemonic to try and recall the ratios. And I'm sure you're going to remember this. So this is, oh hell, another hour of algebra. Now, I used O as a highlighted capital letter, H as well, A, H, O, and A, right? So the first 2 letters, they have to do with sine. O over hell is the same as opposite over hypotenuse. Cos theta, another hour. another over hour, which is adjacent over hypotenuse. Then tan theta, which is the last one, will be off over algebra, which is the same as opposite over adjacent. Now, I'm not going to give you a phrase to remember the reciprocals. Remember that reciprocals is just 1 over the given ratio. So you don't necessarily need to memorize the reciprocals. You need to know the ratios. If you know your ratios, you know their reciprocals. That's clear. So it's like synonyms and antonyms, right? So if you know what the opposite of no is, it will definitely be yes. There's nothing else. So you must just know one word between the two, either yes or no, and then you know the opposite. So it's the same thing as this. You just need to know the main 3 ratios, then the reciprocals will be just 1 over each ratio accordingly. Definition of it will be the ratio if you tip and times it, meaning the numerator and denominator will swap places. So that's what the definition will be. Now, with the reciprocals as well, remember that the reciprocals, we said there's 3 of them. That's cosec, sec, and cot, right? Cosec goes with sine, sec goes with cos, and then cot goes with tan. And you can see my diagram there, which is my triangle, and I've labeled my sides based on theta. I didn't just label them. So this is opposite because it's opposite to the theta. This is adjacent because it's next to the theta. This is a hypotenuse because it's opposite the 90 degrees. And also, one of the big questions people normally ask is, why can I not call the hypotenuse also opposite? Because it's exactly next to theta. It is not adjacent. Why? Because it is one opposite the 90 degrees and also the longer side of the triangle. So you'd really, really need to remember that. Now, a reciprocal, remember, it's 1 divided by the ratio, the numerator and the denominator, they swap. So my 3 reciprocals, remember, it's 1 over sine theta, which is cosec, 1 over cos theta, which is sec, and 1 over tan theta, which is cot. And that's what you needed to look at. So this is just quick revision of what is it that we are talking about when we're talking about a right-angled triangle, a ratio, and a reciprocal, and how they are related to one another. Remember that theorem of Pythagoras, I said you are very familiar with it because we did it in earlier grades of our schooling career, and we know how to talk about the theorem of Pythagoras. But now we're going to look at how do I then use these ratios and these reciprocals to solve for sides, 1, to solve for angles, and how do I go about to do that. Stay tuned, I'll be back with some more just after the ad break. Hi guys, welcome back. So we are still busy with using trig ratios. So we first looked at a revision of what a right-angled triangle is all about. We also went on to look at ratios that we did, which were 3 ratios. We then continued and looked at the 3 reciprocals, which made our total number of ratios to then be 6, right? Because that's the number of ratios that we are dealing with now. But the reason why I'm actually separating the 2 is because you will see we're going to be using the 3 main ratios more than the reciprocals. But if you are given a question that needs the reciprocal, you will then be at a better position to actually answer it. So I hope that has been clear. Now we're going to just go into a revision of what special angles are all about, and then from there we will then apply it later on and see how do we then find maybe an unknown side, a ratio, or an angle, given that it is a special angle, or maybe I'm using a calculator. But we'll look at that at a later stage. So let's just jump right into it. So This has been our mind map, remember our concept map. Right now we are looking at special angles. Now, right-angled triangles with special angles, they look something like this. I have a 30 and a 60 degrees. Reason is, remember that they all need to add up to 180 degrees in a triangle. The other one is 45 degrees, 45 degrees. Why? Because they need to add up to 180 degrees. And then to find these values that I have here, if I am given 2, I can find the third one using the theorem of Pythagoras, right? Or if I'm given an angle and one side, I can find the other 2 sides using the ratios. But that's what we are trying to actually get to as we are continuing with our lesson. Now remember our special angles. With the first lesson we had, I said there were 3 of them. I'm going to also introduce the 0 and the 90 degrees. But these ones, we're not really going to be using them that much. The reference to a 90 is because every right-angled triangle has a 90 degrees. And then the 0 degrees, you will see it will come in handy when we start talking about the concept of a Cartesian plane. But we'll look at that as we are progressing with our lessons. Now, we use the special angles to evaluate the ratios in simple form. What does that mean? It means if I'm given my ratio as a sine of 60 degrees, what does that mean? If I'm given cos of 45 degrees, how can I write it in a simple form, meaning as a ratio that shows a comparison between 2 numbers? Now, the following triangles can be used to determine the ratios of special angles. The first one is an isosceles triangle, which has 2 sides that are equal. I'm sure you are familiar with that. It also has the angles that are equal. The sine 45 degrees, remember that we said it was opposite over hype. That's what sine is all about. And it means that the opposite to 45, it doesn't matter which direction or which angle we are using. If I'm using x, my opposite is 1. If I'm using y up there, this is supposed to be y, the opposite is also 1. So that will be 1 over, my hypotenuse side will then be root of 2. And then you will see at times if you press your calculator, it will want you to rationalize this, because according to maths, we cannot have a denominator that is a surd. So this will be the same as root 2 over 2. But we'll look, I'm sure that you've done under your algebra. With cos, remember cos is adjacent over the hypotenuse side. So this will be the adjacent of either of the 245 degrees is also 1 over the hypotenuse is also root of 2, which then gives me root of 2 over 2 if you rationalize it. Then the last one is tan. With tan 45, remember that the definition for tan is op over adjacent. So op over adjacent, it doesn't matter which 45 I'm going to use, because remember this is an isosceles triangle. So the opposite of this 45 is 1. The opposite of this 45 is 1. So that's just 1 over. The adjacent of either of the 245s is also 1. And then in simple form, that can be written as just 1. And those will then be the first 3 definitions I can give you of 45 degrees. Now, with an equilateral triangle, I'm saying this is an equilateral because, let me just use a different color. This is 2 there, and also this whole side is given as 2. If we were to drop a perpendicular bisector of the third side there, so this will be perpendicular, it will then bisect these 2 sides and make it 1 and 1. Right? So, therefore, this was given as an equilateral triangle with all 3 sides being equal to 2 units. I've bisected the third side and it gave me 1. And if I bisect the third side and it is an equilateral triangle, I'm also bisecting that angle and making it 30 degrees, 30 degrees. Because remember, with an equilateral triangle, all angles are equal to 60 degrees. And then to find the third side, I use the theorem of Pythagoras because of that 90 degrees. So that will make this 2 squared minus 1 squared, and this will be equals to 3, but I want the square root of this, so the third side will actually be square root of 3. That's why that value there is square root of 3. Now, sine 30, remember, opposite over hypotenuse side. So the opposite of this 30 here will be the 1 there, so that's 1 over. The hypotenuse side will then be 2. Cos of 30 degrees is adjacent. Adjacent to 30 is square root of 3 over, and hypotenuse to the 30 will then be 2. Tan 30 is opposite over adjacent. Opposite of 30, that's 1 over. Adjacent of 30 will be square root of 3, like that. And that's what I will then have there. So let me just fix this so you can see it clearly. So this is square root of 3 over 2. And then sine 60 degrees, opposite of the 60 degrees is root of 3 over my hypotenuse side, it's 2. Cos of 60 degrees, it's the adjacent side exactly next to it, which is 1 over 2 again, and then tan of 60 degrees will be opposite over adjacent, which is root 3 over 1. And those will then be the 3, not really the 3, but the 9, if I can say, ratios that we're going to find based on special angles. Remember, it was the 45 degrees ones, and then the 30 degrees, and the 60 degrees, because our 3 special angles are 30, 45, and 60. Now, if the question was to say, evaluate the following expressions without the use of a calculator, the reason why they are saying without the use of a calculator here is that these are special angles there. So the 60 degrees and the 30 degrees are special angles. So you can just quickly remember to draw the triangle that has 30 degrees there. It has 60 degrees there. The opposite of 30 is 1, and then the adjacent is 3, and the hypotenuse side is 2. And then you can then work around whatever that we have here. So sine 30 degrees will be opposite over hypotenuse, so that's 2. I open brackets. Please try to always use brackets so that you don't miss multiplying properly. That will be 1 over 2, then plus the 4 there. Cos of 60, it's adjacent over hypotenuse. My adjacent is 1 over 2, and then I simplify this. So this is why you see that we didn't really need our calculator to do this. 2 multiplied by a half, it's equal to 1, because two halves make 1, plus, and then 4 multiplied by a half, so 4 halves will then give us 2. They make 2, and the answer there will be equals to just 3. The other way of doing this is just to first write the definition, right, to make your life easy. You can say this is 2 open brackets and say O over H, right, opposite over hypotenuse, plus 4 into cos, remember it's A over H, and then you start substituting so that you remember what you are talking about. But remember, I gave you a mnemonic to try and memorize this. You really, really need to make sure that you do remember that. At times, they also use the word Socator, which maybe I will write down right now for you to see as well what does it really mean. That's the other word that we normally use. So at times, maybe you can use the so car, right? Tor, like this. So sine is opposite over hypotenuse, which are these two. Cos is adjacent over hypotenuse, and then tan is opposite over adjacent. I think some of us maybe have seen this in our textbooks somewhere. So that's what you can also use to remember the ratios and their definitions. Now, another question, we're still on evaluating the expressions without the use of a calculator. If they want us to find tan 45 degrees, remember, I'm just going to draw the two triangles. This one is for the 45 degrees, that's 1, 1, root 3, root 2, I mean. So let me erase this. That's root 2. And then the other one will be the one of 30 and 60. 30 there and 60 here. Remember, that's 1, root 3, and 2 there. And then your definitions accordingly, you will then look at tan 45 will be opposite over adjacent, that's 1 over 1, plus tan 30 will be opposite over adjacent as well. So the opposite of 30 is 1, the adjacent of 30 is root 3. I will multiply this by tan of 60, which is also opposite over adjacent. Opposite of 60 is root of 3 over the adjacent is 1. Then the answer here, you can see that if I multiply these two fractions here, I will be left with 1 plus 1 over 1 is also 1, and my final answer will be 2. And then that will be the final answer for me to find there. Hence, you can see that we don't really need a calculator to do this, but we will look at what happens if we are not given special angles. What do we then do when that is the case? The last question is 8 sine 45 degrees minus 16 cos 45 degrees. Now I only have a 45 degree one, so I will draw the 45 degrees triangle. That's 1, 1, square root of 2. I don't need to include the other 45 really, because you know if this is 45 and those sides are equal, automatically it makes the other angle 45 because this is an isosceles triangle. So this will be 8 into sine 45 will be 1 over square root of 2, and then multiply this by negative 16. Negative 16, we multiply it by cos of 45 is also 1 over root of 2. And all of this must be multiplied together, right? So I'm going to use square brackets there. So this will be the same as 8 over root of 2 multiplied by negative 16 over root of 2. And then I will need to find what the answer is. But as you can see, on my denominator there, so this will be the same as 8 multiplied by negative 16. But on my denominator, root 2 times root 2 will just be positive 2 like that. And then you can simplify that further. Let me just include brackets here so you don't think it's minus, because that's one of the mistakes that we normally make. So that's what we really looking at here, using special angles to try and find ratios. The big idea here is to remember the mnemonic that I gave you. Oh hell, another hour of algebra, or the SOHCAHTOA one. Either one. Remember, there's really many ways to kill a cat. If you prefer to use one of them, it's really up to you, especially if it works for you. So we're going to just look at what works for you best and then use that. So that's all that we need to look at. But now we're going to come back from the ad break and then and solve questions that we know we are not given special angles on, and see exactly how we can use our calculator to do that. So stay tuned and I'll be back with some more. Hi guys, welcome back. So we are still busy with using trigonometric ratios. We looked at a quick revision of everything that we've done in our previous lesson, and then we looked at using special angles to find ratios and see exactly how do we then do that. What is it that I need to do to remember my definitions? Remember, I gave you two ways, and also how do I then remember the triangles that I need to use without the use of a calculator. Now we're going to look at equations. Now, if I'm using a calculator, how do I then do that? That's what we're going to look at. But let's just look at the broader picture of what we've done so far. We've looked at the right-angled triangles, and we went on to our ratios, the reciprocals, our very special people, which are special angles. Then now we are still on expressions and equations. We've already looked at our expressions. We're moving on to our equations. Now, to evaluate trig expressions, right? If you are given the angle, you find the ratio. You use a calculator to find the value of, right? So now I want you to use your calculator to find the value of this. Remember, in the previous segment, we found this using the triangle, and this was our 60 there, and this was our 30. It was 1√3, and that was 2. Remember, for us to find the 60 there, and it was cos, it was supposed to be 1/2. So I want you to press your calculator. On your calculator, I'm just also going to show you on mine here. I'm going to press cos and say 60. Close the bracket. Really, some calculators prefer that you close the bracket and you don't leave it open. So just always close the bracket. It will open it for you automatically. And then you hit your equal sign. You see it gives me 1/2. Now, the question will be evaluate the following trig ratios rounded off to 2 decimal places. So now immediately I see rounded off to 2 decimal places. I'm already being told that the answer I'm going to get is not going to be a, let's say, a decimal fraction that we are used to where it's just 0.5 or 0.32. But it is going to be a longer decimal where I will need to round it off to 2 decimal places. So that's what I'm trying to be told there. And how to do this, I will then need to use a calculator for this. So on my calculator, remember we go back to the calculator, you will press, let me just move it here. Okay, so you will press again cos, it opens the bracket, 35 degrees, close your bracket, it gives you the answer. So you can see it's quite a long decimal that I'm having there. But they said rounded off to 2 decimal places. Yes, 2 decimal places. So that's going to be 0.82. So this will be 0.82. And this is when we really do not have a special angle, because 35 is definitely not a special angle. Let's look at one more example. If I say to you, evaluate the following rounded off to 2 decimal places as well, you're always gonna go to your calculator. It doesn't really matter which calculator you are using, as long as it's a scientific calculator. You press your tan there, and tan 36, close the bracket, and then one thing that I know people normally ask is, how do I write the degrees up there? So please, you don't need to write degrees. You're just indicating it when you write it down on paper to show that it's degrees in terms of angle. But with the calculator, automatically, if you press the ratio and press the value, it automatically takes it as a degree. So that will give me 0.73. So this will be 0.73. Now, one example now that I will give you will be, if now they say to me a right-angled triangle has an acute angle of 38 degrees, right? The side opposite the angle is 20.35 centimeters in length. Find the length of the hypotenuse side, right? So I'm just gonna draw this diagram for us to actually look at what exactly they are asking us, right? So I have an angle there which is 38 degrees. I have the side opposite which is 20.35. Remember they said it's a right angle triangle, so there's a 90 degrees there. And then I'm trying to find what the hypotenuse side is. So automatically you can see that I'm given the angle, I'm given the opposite side, I want to find the hypotenuse side. So remember from our short way of doing this, our SOHCAHTOA, right? If I have the opposite and I'm looking for the hypotenuse, it means I need to use sine. So you can see that's what I will need to do. So it means this will be sine of the angle, which is 38 degrees, because remember we named the sides in relation to the angle given. And the side opposite, it will be 20.35 divided by the hypotenuse side, which I don't know, and I will just call HYP, and then I will want to solve for it. So this will be HYP is equals to 20.35 divided by sine 38 degrees, and then I just go straight to my calculator to find this. So let me move it here. This will be 20.35 divided by sine of 38 degrees. Close my bracket. Please try to close it. So let me maybe show you. You see, with this one, it does give us, but at times it does not give you the correct answer. It normally says maths error or something if you didn't close the bracket. So always try to close your bracket. So this will be 33.05. So this will be 33.05 centimeters. Why centimeters? Because we're told that the opposite side is in centimeters. Now, if now we're no longer dealing with expressions and now we're dealing with equations, right? Remember that when we're dealing with the expressions, it's when I'm given the angle and I'm trying to find the ratio. But if I'm now given an equation, it's when I'm trying to find the angle and I'm given the ratio, right? Let's look at this in a particular. Solving that, you consider the ratio or the equation that I've given you down there. Find the angle theta that will result in the ratio being 0.5. We know this from our triangles. Remember, we've been using the triangles, guys. I will always refer to them because they are really important, right? Cos of 60 is normally 1/2, which is 0.5. But to do this, I want you to first look at your calculator. Some calculators may have the button INV or second function instead of the button shift, right? So my calculator that I'm having on the board here, it's shift, as you can see that button that I have there. Now, also make sure that your calculator is on degree mode. What do I mean? At times, it does not really give it to you as DEG. It just gives you D, R, and G. So the D is degrees, the R is radians, which you're not going to use at any time really now. And the G also, we're not using that at the moment. So you always need to make sure that it's on the first letter, the D. Some calculators, it's DEG. Some, it's just D on its own. So you always need to make sure that it is on degree mode. One way to do that is to reset your calculator by pressing either shift or your second function or your NIV, if that's what your calculator has, INV I mean, and then number 3, you see you clear everything, you press your equal, and then the AC. This has cleared the memory and it has taken it to the custom memory it has. So that's how you can maybe take it back to being on degree mode. Now, what do I mean when I say some calculators do not have shift? See, with this one, that's where shift is, right? And this is a Casio calculator, which is also a scientific calculator. Another one will still be a scientific, but a sharp calculator. And this will be the second function there. So that's what I mean when I say you need to look at your calculator. Now, in order to do this, you will first need to press the shift or the second function button followed by the cos, right? What do I mean? We go to my calculator, you press shift, you press cos. See, it will give me cos to the exponent of -1. It opens the bracket. We call this the arc cos, right? Or the second function of cos. So this will look something like that with a bracket there that is opened on your calculator. And then from there, you enter the ratio value. To enter the ratio value, remember our ratio is 0,5, you close the bracket, right? So it means you enter the 0,5. It is just that it's going to be inside the brackets there. It doesn't really show it here. And then, you know, your OK or your enter button is always the equal sign button. And that will give me cos of that in brackets is equals to 60 degrees. Therefore, my theta is 60 degrees. So if I go back to my calculator again, remember enter is equal, then I have 60 degrees. So that's what you need to do there. Please do follow those steps as they are very important to try to find the angle. Now, let's solve the following trig ratios. You are solving for theta if theta is an acute angle. Remember that with this one, I said it's going to be theta is equals to cos to the -1 into the ratio 0,715, and then you press your equal sign, right? So I'm gonna go back to my calculator, shift cos 0,715, close the bracket, and that will give me 44.36 degrees. So this will be 44,36 degrees, and that will be the angle that I have there. And then the next question is, if now it's sec, remember sec, just gonna do this for you. Important, remember that sec is related to cos, right? So it's 1 over cos, right? So it's the same as us trying to find the inverse of, not really the inverse, but 1 divided by the cos function. So here, I'm firstly going to divide by the 2 so that I get rid of whatsoever that is in front of the sec. So this will be sec theta is equals to, not that. So this is going to be, if I divide both sides by 2, it will be 1,23. 1,23, sorry about that. And then my theta will be equals to 1 over the second function of cos 1,23. Remember that there's no calculator that shows sec, cot, or cosec. Right, so I'm just going to go to my calculator and then say 1, let me press this, 1 over the second function of cos 1,23, and I find that, right? So you see, it will give me math error there. So let's just do this. It's 2.46 divided by 2, and then it will still give me a math error there. So that would therefore mean I will first do this, say cos 1,23, will that give me? Yes. So that's the value that I'm actually going to find, but I need the second function of it. So it does kind of work. 3, oh, it's still math error. So I'm thinking the thing that is a problem here will be the value that I've written there. So you can see that's where it will then be. So I will say theta is equals to undefined, right? Not all the time you will be able to find your answer there. So therefore theta will then be undefined. Now, remember the ratios, that's our summary. The ratios, there is 3 of them, and then all 3 of them have what you call the reciprocals that correspond with them. Remember our special angles, there is also 3 of them, that's our 30, 45, and 60 degrees. Remember the 0 and the 90, I said we're just including them because when you start talking about a Cartesian plane, you will see where they come in handy. Also, practice simplifying expressions and solving equations using your calculator. So in simple terms, practice those steps that I gave you. I think it was 3 steps. You press the second function or shift with whatever ratio you want to talk about, enter the given ratio, and then press equal sign. It will then give you the angle there. I hope that clarifies all the concepts that we've been trying to talk about, guys. Remember that we only do this if it's a right-angled triangle. That's the main thing. Although at this point in time, that's the only triangle we're going to be talking about. I mean, continuing, especially in this particular level of mathematics that we are doing. So we're only going to look at a right-angled triangle in trigonometry. And you'll see at a later stage, we'll look at other nice, very beautiful concepts that we're going to look at. But the main thing that you need to always remember is how to use your calculator, please, because a big part of trigonometry at this level depends on you using your calculator and using it correctly. So you can see that whenever I tried to do the other one, it gave me math error. Why? It's because it cannot be 1 comma. It always has to be a 0 comma. So I was just trying to show you the big thing there to say at times, if the first one was 0,713, the second one was 1,23. The 1 comma makes it a math error because with graphs, when we get there, we cannot really cross 1. And you will see that at a later stage when you start doing graphs. From me to you, I will see you next time. Bye, everybody.